All right, we're back again here for another section. This is going to be section 12.4, which is dealing with similar polygons. A majority of what we're going to be dealing with in this section is really just going to be dealing with similar triangles. But we'll just jump into it. So generally speaking, when I've got similar polygons or similar triangles, what I'm going to be doing is I'm going to be using the corresponding sides or angles that are equal with each other as like the basis for how this all works together. So if you look really quick at this diagram here with these triangles, can you see really quick how AED, that smaller triangle, it's kind of embedded inside of ACB? So because I have that embedding, do you see how this angle here, this A, is shared by both of those large triangles? Well, I guess the larger one and the smaller one. It's the same angle. So because of that, I can associate the lengths, the kind of associated lengths with each other as well. So in other words, the length of the bottom part, the leg of this small triangle, corresponds to the length of the leg of the smaller triangle from here, the vertical leg. The horizontal leg here from the bigger one corresponds to the bigger one here. And if I have 1, 2, 3 pieces with a fourth that's unknown, what I can do is use some proportions to set up kind of a, I guess it's a proportion. You can set up a fraction that would essentially figure out or tell you what that missing piece is. So let's just kind of work through it. In other words, here I've got the length AB, the long one, so 24, over AD, the smaller one. You can go small to big or big to small. It doesn't make a difference as long as you keep it consistent. So you'll notice I change it up like periodically on each question, and it's really just like the feel of the question is kind of the way that I approach these. So I'm just giving you a heads up on that. A to B, that length matches A to D. They're similar to each other, or it's associated, you can think of it. And then we're dealing with the longer length here. So the long length to the long length over on the right-hand side, the short length on the bottom to the short length here. Or another way you can do it, there's a lot of different ways you can do these. It's not just like one way. You could do AB over BC is equal to AD over DE. You could do that too. It really makes no difference, because in the end, what's going to happen, you're going to cross multiply, okay? And when you do that cross multiplication, it's all going to multiply out exactly the same, right? You're going to have the product of the means and products of the extremes as being exactly the same. This is kind of like some language that we talked about prior. So if you look at it, I'm going to call this length DE, just this value B. And so I've got 24 over 20, the long to the short, is equal to the long, 18, to the short, which is B. And so when you have this, you can do the 24 times the B here, and then the 20 times the 18, and you're going to find that B is equal to 15. So once you do this multiplication, the 20 times the 18, you take that number that you get and you divide it by 24 to get rid of it on the left. And then once I do that, I'll have my value for B, which in this case is 15. All right. This is something that we can also do to figure out, like if we wanted to figure out the length of AE, we could use something called the Pythagorean theorem. So if you notice really quick, the Pythagorean theorem here, I don't have the actual, well, I think we talked about it before, but the Pythagorean theorem, I can use that to determine the missing length. So it's the square root of this length right there. I don't know if you can see this. This length right here plus that length squared. So this length squared plus that length squared. The square root of all of that is going to give me this short A to E. And then I do the same thing with the length of AC. I could take the square root of AB squared plus BC squared. Take the square root of all that, and I'll get the length, that long length up top. Okay, so there's a lot of cool stuff you could do here. In this case, we just did the AE. I don't know why I didn't do the other one. I'm guessing the question was probably just find the length of these specific pieces. But in any case, that's pretty much how this process goes for all of these problems that we'll work on. Similar triangles is really useful, or similar polygons in general is really, really useful because there's a lot of situations where you're dealing with kind of similar proportions or kind of corresponding angles where they're like matched up, right? And especially in like a lot of different trades, you're going to be utilizing a lot of similar angles, okay, that are connected, and you just have to figure out lengths and matching things up. So let's go ahead and jump to our notes really quick. And I've got I'm going to pull this up really quick because I've got some problems that I'm going to have to pull up here and just as we work on these. There's diagrams that I have to draw that I'm absolutely like trash at drawing. And so I don't want to do that if I can help it. Because let me just say, like, me drawing is like a real adventure for all of my students. I prefer not to be mocked if that's ideal in my world. All right, so first question. We're going to have this kind of thing. I think I can draw this one. This one's not that bad. Okay, this is not a right triangle, by the way. It just looks like it in my picture. So I've got my A, my C, and my B. And I've got a length here. This is a triangle. It does connect there. Just imagine it does. See, I can't even draw triangles. Just imagine how much more ridiculous it gets if the images or the pictures are even worse. So, yeah, it gets pretty funny. I'll just put it that way. Here's a 6. Here's a 6. And what I need to do in this question is I need to find the length of DE. Okay? So the length of DE, which is just this guy right here. I'll put a little red line on it, or blue, I guess, and it looks blue for you. I'm going to call this X, okay? So that way we can just label it as some variable. And so what we can do, since these two triangles right here, here, let me actually show you really quick. I've got two triangles. I've got this thing right here, right? And then I've got another larger one that's like this guy. Can you see that? So there's two triangles. I've got one, and they're matching. They're using the same angle, which is this guy, okay? So therefore, because of that, we can use similar triangles. So what I'm going to do is I'm going to take the corresponding lengths, and then I'm going to do them to the heights. So in other words, the small, I guess, let's just match it up. This is probably going to be easier to track, okay? The small leg here is to the small leg here. 6 is to X. As the long leg here is to the long leg here. So 6, they don't give us the length of the whole thing, so we actually have to add them together. So you see here how this is a 6, that's a 6. The whole length is actually just a 12, so I'm just going to mark that as that such. Okay, you can write it as 6 plus 6, that's fine, it doesn't make a difference, but this is pretty straightforward. And then we've got the 10, which is the other leg, okay? So now as a result, because we've got similar triangles, we can go ahead and cross multiply everything. And so we're going to have 12 times x, again the cross multiplication. 12 times x is equal to 6 times 10. 12x is equal to, this is 60. And now I can divide both sides by 12. And what's going to happen is my 12s are going to cancel on the right, or on the left, I should say. My x here is going to equal 5. So that's going to be my length of DE. Okay. All right, this next one I dare not even draw because it's going to be a complete disaster. So let me Let me try to pull it up here if I can snag it. I think I can. Okay. Wow, this is like using the whole window. I don't want to do that. I just want a tiny little image. Sorry, I'm fiddling with this while you guys are sitting here watching me. You're wondering what I'm doing. I'm on another screen, so I'm trying to make this image just a little bit tinier because it took up the entire window. Okay, here we go. Let's see here. There we go. Oh, man, that's hard to see. Okay. Well, let's go to the next one. Oh, I got to create a new one. There we go. Okay. So let's bring this back up. And so I don't know if you can see this really that well. Let me see here, make it a little bigger. Okay. There we go. That's not bad. That works. Okay. I've got this image. This is like, I don't know. It's like a machining thing. Like if, I don't know if anyone's ever seen those videos where they're like working on machining certain parts just to get them down to specification. But this is kind of an idea of what happens, right? I've got this kind of cylindrical shape, this other cylindrical shape, and I've got a length and a height, or kind of, I guess, diameter associated with like another length and diameter. So this question is actually pretty straightforward. It looks really confusing when you look at it, but it really is pretty straightforward. And what it says is that you've got this kind of 1 to 16 scale drawing. So this is like the 1 in this image, and the 16 is what we need to find. So because it's a 1 to 16 ratio, all we basically do in this question is we just multiply all the pieces by 16 to find what the actual true length would be in the real world, if that makes sense. So you're always like, when you draw on CAD or something like that, you're always going to be using stuff that's a little bit, like, you're not drawing like actual proportions of stuff. Sometimes it's to scale, and then the machine will scale it up when you're building it. So it's kind of the same idea here. So for each piece of these, I guess each length here, all we have to do is to take this, treat it like it's a scale of 1, and then multiply it by 16 to get the 1 to 16 ratio. Okay, so 2 1/4. Yeah, this is going to flip every single time. I'll just tell you what they are. Okay, so A is let's try this again. 2 1/4. Okay, and my suggestion on every single one of these, I mean, I guess you can multiply them all out and work it out if you want, but personally, I'm a huge fan of taking these mixed fractions and then multiplying them out to turn them into improper fractions. Okay, and so if we were to do that, this one would be 4 times 2 plus 1, so 4, 8, 9. That would be the new top. This guy would be the bottom. It would stay 4. And all I have to do now is to find what I'll call A star, okay? And that's basically just the scaled up version. So to find the scaled up version, we're just going to take 9/4 and we're multiplying it by 16. Okay, that's a really ugly 16. Jeez. There we go. So 9/4 times 16, this is going to equal 36. And again, this is going to be in terms of inches, so there we go. Okay, the same thing goes for each piece. I've got all these lengths here, so this is going to be 3/4. And that one's already in its proper form, so I don't have to mess with it or change it. So B star would be 3/4, and we multiply this one by 16. You'll see kind of a similar homework problem on the homework when you work on it. So here we're going to get a 12 inches. Okay. For C, I've got a 1.5. So let's convert this one. This is going to be 2 times 1, which is 2, plus 1, which is 3. And my C star, that's a really bad star, jeez. This is what happens when you rush. There we go. That's a much better star. So I've got 3 halves times 16 as well, again. So these are all multiplying by 16. And what I'm going to get here is going to be 24 inches. And last but not least, my D is 3/16. That's already in its proper form, so my D star is going to equal 3/16 times 16, which in this case is equal to 3. Okay, so that's going to be the solution for these kinds of problems. Okay, normally speaking, you could take the proportion and then multiply them and do all kinds of stuff. We don't actually need to do that in this case because the proportion is just like the scale that they're giving you is already scale of 1. So to scale it up, you just multiply it by whatever the number is, the kind of second number. So now if it was like 2/7 or 2, 19ths or something like that, 2 to 19, then we'd have to kind of do some stuff to make it work. But in this instance, it's a lot easier than that. So maybe that's something you can think about. How would we actually do that? If we scaled it to 2, say we scaled it to 2/7. I'll let you think about that for a minute. Maybe I'll come back and answer that just once we're done. So, all right, let's go ahead and do another problem. Ooh, this one's really fun. I really like this problem because it just is. It really gets that whole like similar triangle vibe. Now let's see if I can draw it. That's the next question here. Okay. Look at that. Let's see here. Hey, that's pretty good. All right. A. This is D. This is going to be C. This is going to be E. That's an E. There we go. That's jeez. Fun times. All right. B. There we go. And so we're given a few of these lengths. So this one right here, let me go ahead and mark it. This is going to be 8.2. This is going to be a 12.3. This is going to be a 10.2. And the bottom is going to be a 20. Okay? So what we need to do here is we need to find length DE. So this guy. And I'm going to call this length X because it's an unknown. And this next one, I'm going to have to do BC. And I'm going to call this one, oh, interesting. So it's the whole length right there. But we're going to need the small one right there, so I'm just going to call that one Y. Okay? And you'll notice really quick, BC is the same thing as whatever I find for that Y plus the 10.2. So we'll do that in the back end. But first, let's start off with the DE, okay? And there's a whole lot of stuff going on here. Can you see really quick that they're sharing this little part of the triangle up top? So the vertex, or the top of the triangle right there, C, it shares that angle. So that means that we can use similar triangles. So there's a lot of ways you can do this. I am going to do it according to the left edge here, okay? So I've got this left edge and then this bottom edge. So we'll do the bottom to the whole left edge. Actually, let's do the small one first. We'll work on the small one. So we've got X, the small base to the small base, which is 12.3. The large bottom over the sum of these two. Do you see how the length here is just the sum of these two values? So that means I've got 8.2 plus 12.3. So 12.3 plus 8.2. Okay? So you can kind of see how a little bit crazy some of these questions can get. You've got combinations of things happening here. So let's go ahead and do this addition first before we do the multiplication, the cross multiplying. I think that'll probably be the easiest route to go. So I'm going to bring this guy over here. X over 12.3 is equal to 20, 12.3, and 8.2. So that is going to equal, what is that going to equal? 20.5? Yeah, 20.5. 20 over 20.5. And now what I can do here is I can cross multiply. So I've got 20.5. I think I drew down here accidentally. There we go. 20.5 times x is equal to 20 times 12.3. And this right here on the right is going to be the same thing as this multiplied out, 246. So it all works out to being a nice round number with no decimal needed. And now the last part of this is we divide by 20.5. And we're going to get x is equal to 12.0 meters. Okay, and these are I should have specified, these are all in meters. So we've got this length. I'll call this one 12.5. 12.0. What am I doing? 12.5. 12.0. There we go. So now that we've got that, we have to figure out this larger length, the BC length, okay? So to do that, let's go ahead and set up another proportion. So let's close this off here. And I'll do it down here. So this other proportion that we have is going to be, let's see here. We got to figure out the y. And so we're going to have to use the right-hand side. So what we can do is we can do the small base to the small kind of, I guess, upper part of the triangle. And then the large base to the whole thing. But you'll notice that it's a missing piece. So, but we can still use it. So let's go ahead and do that. So we've got 12.0 divided by 10.2. So this base to that thing, set it equal to, the corresponding piece would be the 20 divided by, and again, the order does matter here, okay? The order does matter. So if I do the bottom to the side, I need to do bottom to the side on the other one as well. So the side, the whole large side on this one is actually 10.2 plus y. Let me draw that a little bit cleaner. 10.2 plus y. There it is. So that's kind of crazy, right? It kind of creates it's a much more complicated thing than we had before, but we can still treat it exactly the same. We can just cross multiply. So I've got 12.0 times 10.2 plus y is going to equal 10.2 times 20. Okay. And what do we get as a result? So this thing right here, just looking at my notes because I don't want to take too much time with all this multiplication. Oh, see, I did it differently in my notes, but hey, whatever. See, now I need my little... It's good. It's always handy to have a nice little calculator around. Did it differently in my notes, but hey, you know what? Either way works. 12 times 10.2. 12 times 10.2. 122.4. So we got to use the distributive property on this thing, and then this is going to be 12.0y. And then on the right-hand side, I've got 10 times 10.2 times 20, which is 204. Like that, okay? I can subtract 122.4 from both sides, and I'll have 12.0y is equal to 204 minus 122.4 is 81.6, and now we just divide both sides by 12. And we're going to get y is equal to 6.8. Okay? So let me just go ahead and put that up here. All right, so now that we've got the y is equal to 6.8, we actually had to find the length of BC. So it's just this guy right here, the y, and the 10.2 added together. So BC is equal to 10.2 plus 6.8. And in this case, this is going to equal what? 17? 17.0? I think that's what it is. Yep, 17.0 meters. There it is. That's our solution. It took a lot to get there, but, you know, it's a nice problem. It wouldn't be a problem if it wasn't a problem. It's something to think about. Okay. If everything is, the whole point of that, I know this is ridiculous, but the whole point of that was if it's super easy to do all the time, then is it really a problem? It's not really, right? It's all pretty much the same. All right, so on this next question, let me see if I can pull this thing up again, because I actually liked how I had that problem. Oh, not this one. Crap. Next one. There we go. Oh, geez, seriously, I don't need a giant full screen here. Okay, there we go. All right, so here's my problem. I've got an older automobile has a fan belt that's the shape of an isosceles triangle. Okay, that's kind of an important part right there. When you're dealing with isosceles triangles, what it's telling you is that it is a triangle where this length and that length are the same. Okay? So let's go back. What does it say? Shape of an isosceles triangle. Two equal sides are 10 inches each, and the third side is 6. So this is going to be 10 inches, 10 inches, 6 inches. Okay? An older truck has a similar fan belt arrangement, but the isosceles triangle has a width. Okay, that's important. A width of 12. What's the length of the two equal sides of the triangle? Okay, so I've got another triangle like this. This is 12, and I don't know what these are. Okay? So that's what we have to find. We got to figure out what the lengths of these two pieces are on this one. Okay? And the triangle is actually pretty similar. Because it's isosceles, you know, they have the same relative shape. That means that we can utilize similar triangles on this. So the length of the base is to the length of the base, or you could do length of the small of the base to the length of the side of the small, length of the side of the small, or the large, length of the side of the large. So that was confusing. Let me just write it down. Basically what I was trying to say was this, okay? I've got 6 over 10 is equal to 12 over x, okay? Bottom to side, bottom to side, bottom to side, bottom to side, okay? So you can do one size to the other, and it just makes life a lot easier. So in this case, I've got 6x is equal to 10 times 12. So x is going to equal 6x is equal to 120. And that means that I can divide both sides by my 6. And here, I'm going to ultimately get that x is equal to 20.0 inches. Okay, these are all in terms of inches. I should have specified that. In fact, I think the original question had, yeah, inches right there. There it is. Okay. All right, that's actually it. It's the last question I had for this assignment. So if you have any questions, let me know, and I'll be talking to you at some other point. Have a good one.